In the past week, I have been trying to work on a reinforcement learning agent that beats Doom. Let me explain the basics of it first and then how an RL agent can beat a game, and then I'll get on to my specific case. In any RL problem, we have actions, states, rewards, and an agent and an environment. An agent can execute actions in the current state. The environment will change based on the action, and the new state and reward might be sent back based on the change of the environment. Something called the Q table will capture all of these, and it is able to choose the best action based on the state. In the case of Doom, the agent is the main character. The actions are moving left, moving right, or shooting the gun. If the monster is shot dead, a huge positive reward is recorded, and for each second the monster is not dead, we get back a negative reward. Over time, the agent will be trained on these rewards and states, and it should effectively kill the monster. Unfortunately, it didn't go so smooth for me when I tried to train my Doom agent. Here's a preview of the results, and I will talk about everything I try to make this work, but why it probably is still not working. So back to the very beginning, I found a code that implemented Q-table learning with deep learning, aka DQN, in TensorFlow. I ran the code, something fell apart because of the module version incompatibility. So I dug a little bit deeper. Turns out that when we download VizDoom, which is a virtual environment of Doom that you can send actions to in order to get the state and rewards, it comes with a sample code for DQN. It is written in TensorFlow, so I ran the code and then the model performed fairly well. But I'm just not a fan of using someone else's code without understanding it, so I try to implement the same concept and algorithms in Keyless. What I don't like about the original code is that there was an agent class that had methods like get actions based on the state, but there was a separate class that stores memory so that we can train our agent later with batches of the memory. The memory might include the state, the actions, and the rewards based on the actions. But I don't think this memory thing deserves a whole separate class. I think it can be stored in a single variable. So my attempt was to write this into a variable that belongs to the agent class. I was able to write this code successfully and turning this 321 line program into one just about 200 lines without the comments. The code looks cleaner, but I ran into some major issues with this code. I used the hyperparameters I trained my Atari breakout agent with on Doom, and that was a learning rate of 0.0001, a discount factor of 0.95, and an exploration rate decay of 0.995. I want to get into epsilons and exploration rate real quick. It seems to be one of the first and important parameters to tune in any RL problems. Epsilon determines how much the agent is allowed to explore. So when the exploration rate is high, the agent randomly chooses an action instead of choosing the action based on the Q table. If the exploration rate is low, the agent will exploit and use the Q table. And that is really important because if your exploration rate is too high and it decays too slow, then the agent is going to get a taste of everything, but it is not going to converge its loss because it's taking random actions. If the exploration rate is too low, your loss might converge, but your training agent might not have seen enough stuff yet, and when it sees the brand new state, it might freak out. I tried to tune in the epsilon greedy policy and other exploration rate tuning methods a lot, but none of these ended up with my model converging. Now the losses actually converged, but the performance, as you saw earlier, was horrible. The agent just walked to the left or right continuously and then just shot randomly without regard to where the monster is, which it should be taking actions towards the monster because killing it will return the highest potential reward. So yeah, I still have a lot of stuff to tune. I am sorry if you expected an awesome tutorial, but turned out I'm literally just documenting my failures. But I love the process, and if you enjoyed my explanation towards why my code is probably failing, then make sure to drop a like and subscribe. Next time I see you, hopefully I have beat this Doom game. See ya.